In this video, I'm going to discuss about the measurements of water activity. But first, what is water activity? Water activity, denoted by AW, is a measure of the free water in a system available for microbial growth. It's defined as the ratio of the vapor pressure of the water in a material to the vapor pressure of pure water at the same temperature. It's a key factor in food safety and shelf life. It means water activity is like a water score for food. It measures how much water is available in the food for bacteria to use. The higher the score, the more bacteria can grow, which can make the food spoil faster. So it helps us understand how long the food might last before it spoils. Now, let's proceed to the 4 methods of measuring water activity. First, the desiccator. This equipment containing sulfuric acid or salt solutions. What are its functions? Maintain a low humidity environment for moisture-sensitive items such as fruits and vegetables. Next, comprising an airtight container with a lid, they employ desiccants like silica gel or calcium chloride to absorb moisture from the air inside when sealed shut. This dry environment preserves the integrity of chemicals, electronics, or hygroscopic materials within. It needs periodic replacement or regeneration as they become saturated, ensuring continued effectiveness in safeguarding against moisture. Second, the Winkler Method. The sample suspended in a vessel with saturated salt solution and weighed continuously by a bottom weighing balance. Oxygen combines with manganese hydroxide to form higher hydroxides, which acidification liberate iodine equivalent to that of oxygen. In simple terms, when oxygen comes into contact with manganese hydroxide, they react to form a new compound called a higher hydroxide. If this compound is then exposed to an acid, it releases iodine. This iodine is titrated by a standard sodium thiosulfate solution, using starch as an indicator. This is the formula to calculate the dissolved oxygen using the Winkler's method is equals to volume of titrant, multiply by the normality of the titrant, and multiply to 8.8. And the 8.8 in the formula is a conversion factor. It helps convert the volume and normality of the titrant into the amount of oxygen in milligrams per liter, mgl. And where the volume of the titrant is the volume of the thiosulfate solution used to reach the end point, and the normality of titrant is the normality of the thiosulfate solution. The application of Winkler method is used to measure dissolved oxygen in freshwater systems. It is used as an indicator of the health of a water body, where higher dissolved oxygen concentrations are correlated with high productivity and little pollution. Dissolved oxygen analysis can be used to determine the health or cleanliness of a lake or stream, the amount and type of biomass a freshwater system can support, the amount of decomposition occurring in the lake or stream. Next, the dynamic method or dynamic vapor sorption, DVS, is a dynamic method for measuring water activity. It measures the vapor pressure of a sample directly. Water activity is calculated from the ratio of the sample's vapor pressure to that of pure water. DVS is fast, reliable, and overcomes drawbacks of traditional methods. Factors like pre-drying/wetting techniques and time for moisture uniformity can impact accuracy. This is the dynamic vapor sorption analyzer. It measures the rate and amount of solvent absorbed by a sample. It uses a gravimetric technique, varying vapor concentration around the sample. It uses to measure water activity in materials and can work with various solvents. The analyzer ensures gravimetric equilibrium at each humidity level. The equilibrium mass values generate the isotherm. Once the sample is inserted, the DVS device operates automatically. Application of the method. Pharmaceuticals, foods and feeds, fertilizer and agrochemicals, fine chemicals, detergent and cosmetics, building materials, electronics. Let's proceed to the last method, the spring sorption balance method. The food sample is suspended from a calibrated coil spring whose extension or contraction is followed by a canthotometer or recorded electronically. Here's the illustration. These methods involve samples of known initial moisture content which go through the process of moisture gain or loss in a constant relative humidity atmosphere. There is an approach that is to place the food sample of known constant moisture content in a sealed enclosure with a headspace. There is a method that is a quicker, less precise method to determine relative humidity levels where samples neither gain nor lose weight. By using samples with various moisture contents, the food's sorption isotherm can be plotted. The details of the water activity measurements are found in reviews by Gall, 1967, and Toledo, 1973. The methods of partial pressure measurement using a simple manometric technique is given by Taylor, 1961. Carroll, 1955, is given by using a hygrometeric technique. Water activity is important because measuring it is crucial as it directly impacts food safety and quality. It influences microbial growth, shelf life, and chemical reactions within food. By controlling water activity, we can predict and prevent food spoilage, ensuring the safety and longevity of food products. Make sure to hit that subscribe button, smash that like button, and make sure to leave some comment. Thanks for watching.